So first things first. So today we're going to talk about systems of linear inequalities. We talked about just plain old linear inequalities last time we met before break, and now we're going to talk about systems of those. And I'll show you how to use technology to graph them, and we're going to look at maybe a quick application of this stuff. And that's it for today. All right, so let's start off here with a simple system of linear inequalities. Anytime we have a system of something in math, excuse me, remember that just means we've got more than one of those things taken at the same time. So when I have a system of two linear inequalities like this, if I want to find the solution set, I'm just going to graph those two inequalities and figure out what are the points that are parts of both graphs at the same time. Okay. So let's go through and let's maybe graph each of these individually, and that will be a review of the stuff we did right before break. So let's take this guy first here, this top inequality. Oops, blue. This will be our blue inequality, and I want to graph that thing. Akira, how do I graph a linear inequality like that? Remember, this is the stuff where I've got a boundary line and a shaded half plane and all that stuff. Okay, good. So we see that my y-intercept is -1, so that's going to be 1 point. And then our slope on that first one is -2/3. Remember, we always group the negative with the top, right? So the rise is -2. So we're going to rise by -2, which means I go down 2, and I run by +3, and that takes me to there. Is this going to be a dashed or a solid boundary, Akira? Solid. It's going to be solid. Good. And we know it's solid because we're including that equal sign, right? If I didn't have the equal sign there, the boundary line would be dashed, which means that it's only a boundary. It's not included in the graph, in the shaded half plane. But if we have an equal sign there, it's solid because it means that the line actually is included in that shaded region, okay? So here we've got our solid boundary line. And then I want to know now, Alara, which way do I shade, up or down on this one? Do I shade above or below that boundary line?
Below.
I'm going to shade below. Good. And you saw this part here, didn't you? We want the y values that are less than or equal to our boundary line. Well, y is our vertical variable. And when we're speaking about vertical stuff, less than would mean below, wouldn't it? And greater than would mean above. Okay, so this is telling us we're shading below. And so here's what our shaded region would look like. Okay, there it is. So there's our first inequality. Everybody give me a 1 to 5 real quick on that. Just I want to make sure everybody's okay with, this is ringing a bell, all the stuff we talked about before break. So you can just show me fingers or type it in chat. Okay, all right, well, for the most part, it seems like, we're going to get more practice. So if you're not feeling 100% on this, don't panic. Okay, now let's do the other one. This one will be red. So for the red inequality, Tony, help me out with the boundary line first.
So you start at -8.
Okay.
And you go up 1/2 for the x.
Okay. Solid or dashed boundary?
Solid because of the equals.
Good. Okay, so we get solid. Very good. And am I going to shade, Aurelia, am I going to shade above or below the boundary line this time?
Above.
Above, good, because I want the y values that are greater than the boundary line. So we will shade above. Oh, come on. So it's all that stuff, right? And then what is our solution going to be, right? The solution must be just like it was with linear systems. With a linear system, a system of linear equations, let me be more specific. When we graphed that, we had two lines, and the solution was the point of intersection because that was the only point that was on both of the lines at the same time, right? Well, in this case, it's a little bit bigger than that, isn't it? Right? The solutions involve boundary lines, but also shaded half planes. So the solution must be the overlapping region then. It's the collection of all of the points that are part of both shaded regions, right? So you can see it's this part in here, isn't it? Well, let's make it a little more obvious. Let's make it purple, how about? So here's the solution in purple. Okay? And we would include also, we'd want to include this part of the boundary line. We can see that the upper boundary of this region is a solid line, so we want to make sure that we see that that's solid, and the lower boundary of this shaded region is also solid. Okay, so there it is. Okay, give me 1 to 5 real quick. Does that all make sense? Okay, good. We had two inequalities in our system, and so the solution must be the double shaded region. Okay, I'm going to show you how you can do that on Desmos real quick. It's super easy to do. Okay, all you have to do on Desmos. Come on. There we go. The only part that you may not be sure, I bet you could just guess how to do this, but I bet you're wondering, how do you get a less than or equal to? Okay, well, all you have to do on Desmos is I'm going to type this in. Y is less than negative 2/3. Oh, how come that's, I got it in the wrong spot. Never mind. Hang on here. I put it up here. Y is less than negative 2/3 x minus 1. Now look what it did though. When I have the less than symbol, notice that it made the boundary line dashed like it should. Well, how do I get a less than or equal to? All you do is right after you type the less than, you immediately type an equal sign, and it puts them together and it makes the boundary line solid. How about that? Desmos is pretty smart. Okay, so there's the first one. Y, here's the second one. Y is greater than or equal to 1/2 x minus 8. And what do you know? Okay, it gives us, there's our solution set, right? It's that double shaded region. Okay, and I've got a picture of that on here for our notes. So there's a little, just to remind you how that works. There it is. Okay, let's try another one. This one is maybe just a step or two harder than the last one, though. How come? What's different about this one? Brogan, what do you see different about this one that makes it look maybe a little tougher?
The X and the Y are on the same side.
There you go. The X and the Y are on the same side. I've got to put this into slope-intercept form. I got to isolate that Y, don't I? So let's deal with this first one up here, Brogan. Help me out with this one. So we start off with 7x plus 3y is less than or equal to 18, and I got to isolate that Y. What are the steps going to be to get that Y by itself?
Would you just subtract 3y?
Well, I'm gonna leave the Y where it is on the left side. So you're on.
Okay.
So
Would you just subtract 3?
I can't subtract the 3 because it's being multiplied. But what about this term over here?
Subtract the 7.
There you go. Subtract the 7x. right? I'm going to take that term that's being added to the 3y, and I'm going to move it over here by subtraction. Okay, so that'll cancel that, and that's going to leave me with, on the left side then, I've got my 3y. That's closer, right? I'm trying to get that y by itself, and that's less than or equal to the combination of 18 plus negative 7x. Well, I'm going to put the x term first because we're trying to put this into mx plus b form, right? So we'll put the negative 7x plus 18. Okay, last step, Brogan. How do I undo multiplying by 3?
Divide.
There you go. I'm going to divide both sides by 3. Now, on the right side, I've got two terms, so I'm just going to go ahead and divide them individually. It makes it a little bit easier. I'll split up that common denominator, right? And then look what happens. The 3's cancel, and I get the y by itself. Y is less than or equal to. Now, notice here, I've got negative 7x divided by 3, but I want this to look like mx plus b, so I'm just going to group the negative 7/3 together, and that's my slope, isn't it? So y is less than or equal to negative 7/3 x plus 18 over 3 is 6. So there I've got it. I've put my red inequality into slope-intercept form. So Gabe, help me graph that, please. Start with the boundary line.
Graph 6 first.
Okay, good. So I start with a y-intercept of 6. And what's my slope?
Negative 7/3.
Okay, so what's that tell me to do?
7 down, 3 across.
There you go, good. So I go 7 down. I'm going to go 3 to the right. Very good. And that puts me at a point right, whoops, I got to be red. There's a point right there. And Gabe, is this boundary line going to be solid or dashed?
Solid.
Solid, good, because we're including the equals. Very good. Okay, am I going to shade, Jade, am I going to shade above or below the boundary line for the red inequality?
Below.
Below, good, because I'm y is less than or equal to. Good, so we've got that's below, right? Okay, good. Now for the blue one. That'll be the bottom one. I got to get the y by itself in the bottom one. Mr. Thatcher, what do I have to do to isolate that y in the bottom one?
Get the 2x to the other side.
Okay, good. So I'll subtract it away.
Yeah.
So that cancels, and we get negative 3y is less than or equal to, let's put the x term first, so negative 2x plus 9. Last step.
Divide by negative 3.
There we go. So divide.
And so then you have to switch to the thing, right?
Ah, very good. Okay, good. So we're going to divide everything through by negative 3, which means I've got to flip that guy around, doesn't it? So we end up with a y is greater than or equal to negative 2 over negative 3. Well, negative divided by negative becomes positive 2/3 x. And then we get positive 9 divided by negative 3 is a minus 3. Okay, good. So there's our inequality written in slope-intercept form. James Weller, help me with that boundary line, please.
We start at negative 3.
Okay.
And then we go over, no. Yeah, we go up to and over 3.
There you go. Up to, and we go over 3. And we end up right there. What do you know? Same point as last time. And then solid or dashed boundary.
It's solid.
Good. Jordan, am I shading above or below the blue boundary line?
Above.
Good. Shading above because y is greater than or equal to. So if we shade above, there it is, right? Now it's kind of hard to see there, but let's graph the double shaded region in purple. It would just be this region right here, wouldn't it? So there's our region. And then we know we can see that the upper boundary is solid and the lower boundary is solid again, just like last time. Okay, I want to show you when we do this on Desmos. I mean, you guys are already familiar with this, but if I do this on Desmos, one nice thing about this is I don't have to put those into slope-intercept form. Desmos is very convenient that way. So we've got I can just leave it as 7x plus 3y is less than or equal to 18. There it is, right? Don't have to solve for y. And then for the next one, 2x minus 3y is less than or equal to 9. And there's my solution set. I'll put that on there for your notes. How about? There we go. Okay, what about an application? Something like this. Okay, why might we need these things? Well, let's look at this situation here. We've got Darcy is buying some fruit. She's buying apples and oranges for a large fruit basket to give away as a door prize at a charity event. Apples cost 24 cents each and oranges cost 80 cents each. She has $12 to spend and would like to purchase at least 20 pieces of fruit in total. Okay? All right, so first of all, we, like always when we're dealing with an application like this, we need to identify what our unknowns or our variables would be. Now, think what it means to be a variable, right? A variable is something that can be varied. So what are the things that Darcy has control over here that she could vary? Kylie, what do you think? She has some choice in this matter, right? What can she choose? Okay, no Kylie. How about Landon? Okay, number of each kind of fruit, right? Good. So we could say, how about if we say X is, let's do X is the number of apples and let's let Y equal the number of pieces of orange, or number of oranges, right? Okay, good. So then now we just need to come up with, let me see something here real quick. Okay, there we go. Yeah. Now we just need to come up with some inequalities, right? And these, we'll see why these are inequalities in a second. So we know apples cost 24 cents each and oranges cost 80 cents each. And Darcy has $12 to spend. Okay, she has $12 to spend. Could she spend $11? Give me a thumbs up, thumbs down. Or yeah, there we go. She could, right? She could spend $11. Could she spend $12? Sure. Could she spend $13? No, It's not going to work. She doesn't have that much, right? So the amount of money that she can spend must be $12 or less. That sounds a lot like an inequality, doesn't it? Right? Doesn't that sound like the amount of money she can spend is less than or equal to 12? The amount of money she spends. So we just need to come up with some expression that calculates how much money she spends, right? We know X is the number of apples and Y is the number of oranges, and each apple costs 24 cents and each orange costs 80 cents. Okay, so McKenna, can you come up then with some kind of an expression that's going to calculate for us amount spent?
Would it be 0.24 x plus 0.8 y is less than or equal to 12?
Less than or equal to 12. Perfect. How about that? So what calculates the amount spent is that 0.24x plus 0.80y. Doesn't that make sense? The cost for each apple times the number of apples is telling us the amount she's spending on apples. And the cost per orange times the number of oranges tells us the amount she's spending on oranges. And the total has to be less than or equal to 12. Good job. Okay, there's another piece of information up here that we're told. She would like to purchase at least 20 pieces of fruit. So would 25 be okay? Thumbs up, thumbs down. Sure, that works, right? She'd be happy with 25. What about 20? Yeah, she'd take 20. What about 19? No, she wants at least 20, so 19's no good, right? So that sounds like an inequality again, doesn't it? It sounds like the total number of pieces of fruit that she's buying should be greater than or equal to 20 to meet her criteria, right? So what's our expression here for the total amount of fruit that she's buying? If X represents the number of apples and Y represents the number of oranges. What do you think, Melinda?
So do you want the equation?
The inequality? Yeah, why don't you give me the inequality?
Okay, would it be like the same as the top, but but then it would be greater than or equal to 20?
Okay, but this time now on the top, remember that when we multiply 0.24 times X, that's calculating the cost of the apples, right? See what I'm saying? And this is calculating the cost of the oranges. This one's a little simpler. We just want the total number of pieces of fruit to be greater than or equal to 20. So we just need to come up with some expression here for the number of pieces of fruit. Boy, this thing doesn't write beans. X is the total number of apples and Y is the total number of oranges. So what's the total amount of fruit that she's buying?
Is that just the 20 pieces in total?
Sure, right. But the 20 pieces is what she wants, at least 20. So something needs to be greater than or equal to 20, right? She wants at least 20 of those pieces of fruit. But what's the expression here in terms of our variables that's going to tell us how many total pieces of fruit she's buying? If X is the number of apples and Y is the number of oranges.
I'm not sure.
Okay, that's okay. Anybody got an idea for that? I'll just throw it out to the group here.
Would it be like X plus Y?
Ah, there you go. Yeah, just X plus Y, right? The number of apples plus the number of oranges combined has to be greater than or equal to 20. Does that all make sense? Everybody give me a 1 to 5 on that, just that little concept there, the red concept. Okay. All right, so we got our two inequalities. then all we have to do is just look for the intersection of those, right? Okay, let's do that. Let's do that. But let's use technology to do this. How about? Okay, so the first one we'll do is 0.24x plus 0.8y is, can't see, I got to move this over a little bit, is less than or equal to 12. Okay, that gives me that whole region. And then I also want the inequality x plus y x plus y is greater than or equal to 20. Okay, and we can see there that that gives me that purple overlapping region, right? Okay, that gives me the collection of all of the infinite points that are part of our solution. Each point has an ordered pair, right? Well, the second part of the question just wants us to give two possible combinations, right? So really, I'm just giving values of x and y. Those are points on my graph. What seems wrong? Can anybody see something wrong with this? Look at our double shaded region. Are there some points in that region that really don't make sense as solutions? What do you think, Melinda? I see you shaking your head. What doesn't work?
Well, I mean, there's a point where like you just can't purchase so many numbers of that fruit. Like the shaded section goes on forever, but we can't necessarily do that.
Okay, it goes on forever. You're right. Like, what about this point right here? You see where I've got to look where I'm pointing right there. Yeah, does that one make sense? Look at the coordinates of that point. Let's just type in some coordinates here real quick. So I'm going to pick two of them. Let's pick one. I'm going to zoom in just a little bit here, like this. Okay. There we go. Let's see. There we go. Perfect. Okay. So it looks like, would everybody agree that when x is 25 and y is 5, that's one solution? Everybody agree? There's one, right? What does that mean, by the way? What does that solution mean? What's that telling you about the fruit that we're buying, Savannah? The ordered pair 25, 5 corresponds to a point that is in our double shaded region. So that's a solution. What's that mean? What's that tell you about the fruit she's buying? Oop, we got some kind of weird. Why don't you go turn your mic off, Savannah? Something weird's happening. I'm going to skip you. I know you had it there, but something crazy was happening there. Chavano, how about you? What's that mean? Questions for Chavano. What's the significance of that ordered pair? Okay, what do you think, Jordan? What's the significance of that? The ordered pair 25, 5. That's a solution. What's that telling us? Yeah, 25 apples and 5 oranges would work, right? That would satisfy our criteria. Okay, what were the criteria again? Let's review this. Okay, well, she could buy it. She only has $12 to spend, so she could afford 25 apples and 5 oranges, and that's at least 20 total pieces. So yeah, that one works. Okay, good. So there's one that works. The graph is telling me, according to this double shaded region, I could also have the point. It looks like if I go over 30 and down 5, that's another point that's in my shaded region. Does that make sense to you, James Thatcher? Does that seem reasonable? The ordered pair 30, negative 5? What's wrong with that?
What's wrong with it?
That doesn't seem possible to me. What's that trying to tell you? X is 30, which that's the number of apples, and Y is the number of oranges is -5? That doesn't seem, yeah, you can't have negative number of oranges, can you? Yeah, so something's not right with that. That doesn't seem right. We must have to do something else to our system here because that should not be included in our solution set, should it? When we have something like a real thing like an orange or an apple, we can't have a negative number of those. Okay, so what else could we maybe add? What other inequality could we add there so we don't get a negative number of oranges? What could we do? Y is the number of oranges. James Weller, you have an idea? Looks like you raised your hand.
I was going to say something along the lines of anything that is below that zero line we take away
Okay,
somehow.
that's right. So that's our goal. We want to only include stuff that is above the x-axis, right? Okay, so that means, let's think about that in terms of the number of oranges. We could think about it mathematically in terms of a graph, or we could just think about this in terms of the actual problem, right? We can't have a negative number of oranges. Would everybody agree with that? The number of oranges we could have has to be non-negative, which means it could be 0 or positive. We could have 0 oranges. That's possible. We just don't buy any oranges, but we can't buy a negative number, right? So let's see what happens if we just graph the inequality. Y is greater than or equal to 0. Well, hey, look what happens. That shades everything up above the x-axis. That's a pretty bad color. Let me pick a better color on this. How about something like orange? That's a little better. Now look what that does. Now that just excludes everything below the x-axis like James suggested, and we're only keeping the values above the x-axis, only the positive values of y, right? And really, we probably should do the same thing for x, shouldn't we? Because we can't have a negative number of apples either. So we should probably have the inequality x is greater than or equal to 0 also. And let's change that color. Let's make that like green. How about? Right, and so then that gives us, it doesn't really change anything, does it? Because we didn't have any negative x values in our solution set anyway. But we probably still should have that inequality there. Everybody see that? And so now we get this triangular region, which makes more sense. It doesn't include negative values, right? And so let's just pick 2 positive values from this one. Let's get rid of the 30, -5, and let's pick another one that fits in this triangle now. Like what about over 15 and up 10? That would work, right? Okay, so there are 2. Make those black. There we go. How about that? Right now we've got 2 solutions, and so those are 2 things that would work. She could buy 15 apples and 10 oranges or 25 apples and 5 oranges, and both of those would be valid. Those would both work. Okay, does that make sense, everybody? Okay? All right. Here, you know what I'm gonna do? I'm gonna replace this graph. Our new one's, I like our new one better. Our new one's got the ordered pairs in it. So I'm gonna, oh, whoops, that's the wrong graph. No wonder. What did I do here? There we go. Yeah, let's get rid of this one. And I'm gonna take a picture of this guy instead, and this is better. There we go. Okay, so for your notes. All right, last issue then. Really, this is one that I don't feel like we even need to go through this again. I feel like you guys get the hang of this, right? So if I wanted to graph a system of 4 linear inequalities like this, really all that means is I'm going to graph each of those 4 inequalities, and then I just want to see where the quadruple overlapping region is. It has to be the region. If there's a solution, it's the part that is shaded by all 4 inequalities. So if I graphed all 4 of those in this case, right? So the top one is blue, second one is red. It looks like I mixed them up. The x is less than 4 is orange, and y is less than or equal to 2 is green. Then look what we get, right? We get this solution down here is this, this one part that's shaded all 4 times. Does it make sense? Do the x's make sense, by the way? If I graph something like, does this make sense? I'll put this up in Desmos. What if I just graph x is greater than or equal to 0? Does that make sense? The boundary line is the line x equals 0, which is a vertical line, right? Everybody see that? And if I'm graphing the x values that are greater than 0, well, x is the horizontal variable, and so greater x values should be the values on the right. Everybody give me a 1 to 5 on that. Does that make sense on that x part? Okay. All right. Then I'm gonna turn you loose a little bit early today then. It's 5 minutes. I'm going to give you a chance to kind of get up and stretch your legs a little bit before advisory. I feel like we covered this stuff. Any questions? Okay, I'll be here after school if you need to test or retest, because some people are still missing tests and that's hurting your grades. Or if you have any questions about the homework, I'm always here. Come see me. If I don't see you during office hours, I will see you on Thursday. Homework assignments are up. Have a great day.